All right, we're going to begin this semester with lesson 1.02, solid shapes and 3D drawings. There's a few things I want to cover with you though before we dive into the lesson. These are just some need-to-knows. When you're completing the weekly assignments, what you need to do is be sure to watch the lesson videos just like you're doing now, and then you need to go through and read the lessons carefully in the LMS, complete the student guide. This is like taking notes in a brick and mortar school. Then you need to complete the problem sets for each lesson, and at the end of each lesson they will tell you what problems you need to complete. You won't have to do the whole set. And then you also need to use the reference guide. Read up on whatever you need to in that section. It has more explanations and kind of different explanations in it. And then attend CC tutoring in Toga. And I personally will be in Toga on Tuesdays, but you can attend Monday through Thursday from 3 to 4:30 any day. And always ask questions before you take the quiz. There are no retakes or corrections on quizzes. If you do have questions regarding your lessons, do the following in this order. First, you need to go to raise your hand in the unit because someone may have already asked the question and received an answer, and if not, just go ahead and post your question and check back later for an answer. I do check the raise your hand section at least 3 times a day, usually more. IM me at TPOER_TXVA. Even if you use Windows Messenger, you can send me your ID and I can add you. You can also send me a K-mail with your course name and section number. That's very important because I won't be able to respond to you without it. Also, be detailed in your questions so that way I can best help you. And call me if all other avenues have failed. I make this our last resort because it's really hard to talk about geometry over the phone. And be sure to attend CC and tutoring in Toga just like I mentioned earlier. Now, this week's assignments not completed by this Sunday will become zeros on Monday. Now, on Friday, I'll be sending out a K-mail going, hey, you haven't finished all your assignments for this week. And then on Monday, I'll say, hey, you didn't finish all the assignments over the weekend, so now you have a 0. And if you have extenuating circumstances and you've made me very aware of them, do not be alarmed if you still receive these K-mails. All right, they're reminders to help you stay on top of your work. And lastly, if you will go to, in your LMS, you'll see it says Unit 1, raise your hand, that's where you ask questions, and then under that it says Unit 1 resources. There's a whole lot of stuff in here that can help you better understand the material that we're studying. And there's unit resources for each unit. Now on to our lesson today. The first thing that you're going to need to do, or we're going to learn to do, is interpret three-dimensional drawings, and then we're going to define and use characteristics of three-dimensional drawings. Doesn't sound like much. Here are some new terms that we're going to be going over: depth, three-dimensional drawing, perspective drawing, isometric drawing, and solid. Okay, figures in 3 dimensions. I've drawn this is an isometric drawing right here, and we'll be talking about it more in detail later. And if you want to go crazy, this is an isometric drawing as well. It just doesn't have all the dots behind it. Alright, anytime you see a segment, all these are segments, those are all called edges. Okay, these points that you see where the segments end, each one of those is called a vertex. Altogether they're called vertices. Each point is a vertex. And then each one of these squares that you see here, because this is a cube, is a face. Alright? Now then, we can look. Here is the top face, bottom face, and you see all the vertices. We've named them with the alphabet. Now let's look down here. It says depth could be represented by section AD, or segment, segment BC, segment EH, and segment FG. And your width could be represented by AE, BF, DH, and CG. Now notice this says could be, and you'll learn that it could be others. But when we look at this, this is the main thing we see. Width is sometimes referred to as height. Okay, what I need you to do is read about perspective drawings in lesson 102 in the LMS and in your reference guide, and it begins on page 176. Just some of the basics that you need to know about perspective drawing, which this isn't particularly what we need to know about them, because a perspective drawing can be of anything, not just a cube, so we're talking about cubes here. Cubes have 6 faces. Always count the ones you can't see. And for example, that's the left and bottom of the cube below on the left. Okay, on this cube down here, you cannot see the left side and you can't see the bottom of the cube. You also can't see the back. Alright, all we can see is 3 faces, but there's 3 faces we can't see, so altogether there's 6. Cubes have 8 vertices. That means they have 8 points. Okay, so you're going to look at the corners, what some of you like to call them. There's all the corners. Each one of those is a vertex, and there's 8 of them on a cube. And then cubes have 12 edges. Okay, there's 12 segments all through here. And then what I wanted you to see about these perspective drawings is this is from a 1-point perspective. And what they mean is they're talking about this vanishing point back here. See it right there? That's a 1-point perspective. This drawing, perspective drawing on the right, is a 2-point perspective. And you can see there's 2 points here. And what you do need to know is that this line going through the 2 points is always called the horizon. Next, we're going to talk about isometric drawings that show 3 sides of a solid figure from a corner view. And I had a picture like this on the first slide and said, hey, this is an isometric drawing. Well, this is what it looks like. The view from the figure of a corner is called the corner view or the perspective view. You can use isometric dot paper to draw the corner view of a solid figure. You will have to do an isometric drawing on the unit test part 2. So I'm going to go through here and give you some tips on drawing them. Now, this particular sketch that we're seeing here, there's 4 steps to it. And they're drawn a rectangular prism that's 2 units high, 5 units long, and 3 units wide, using isometric dot paper. I'm going to be providing a copy of these slides in doc sharing, so you can go through there and look at this closely while you practice drawing. And you can download isometric graph paper from doc sharing or anywhere on the internet. Matter of fact, I'm making me a note right now to put it in the doc sharing. Okay, that is done. Alright, now I'm going to take each one of these steps and also go through and draw a triangular prism so you can get the idea. This says sketch a triangular prism 3 units high with a base that is a right triangle with legs that are 2 units and 4 units. Okay, remember this one that we drew on the previous slide, that was a rectangular prism. But I wanted you to see step 1, mark the corner of the solid. So we're doing a solid that's a triangular prism. And to mark that corner, what I'm going to do is going to go ahead and do the legs. This is what I drew first. The legs of the right triangle. and it said that the legs were 2 units. This one's 2 units, and this other is 4 units. See, I'm going to go from this corner, 1, 2, 3, 4. It's not quite all the way there. That's why I want you to hand draw these, because when you try to draw them with the computer, it just never works. But I also can't draw with the bamboo pad. I've tried over and over again, I just can't do it. So I'm doing this with the computer and cheating. Alright. Step 2. Now this says draw a parallelogram for the top of the solid. Well, we're doing a triangular prism, so our top is not a parallelogram, it's a triangle. So what I did was added the hypotenuse to the triangle that I had already begun. God, I'm glad I teach math. Okay, next it says draw segments 2 units down from each vertex. Okay, well, I already had this height right here drawn that's 3 units. So what I needed to do was draw that same height from the other 2 vertices. So I drew this segment, and then I came down here and I drew this segment. Okay. And then it says just connect them. So what I did was I went and I connected these guys in the back, and then I connected these guys in the back on the bottom, and then I added this dashed line for the hypotenuse in the back. And ta-da! I've drawn my isometric drawing of a triangular prism. Those you just got to practice with, I promise. I had to practice with them. Okay, now we're going to go through some examples. This drawing of a cube uses a 2-point perspective, and it has a front edge BF. Now, don't get confused, because I confuse myself when I'm doing this particular example, because F and D look like they're the same point. They are not. Okay, D is the point that's in the back. F is the point in the front. So BF is my front edge. Okay, let's go on to the questions. Which line represents the horizon? Well, I told you earlier that whenever you have a 2-point perspective, you're going to look at these points that are in the back, the vanishing points. Okay? Those vanishing points are J and K, and through J and K is the line. So when you get ready to name that, you have to name it as a line, JK. The next question says, which point or points represent the vanishing points? You had to figure that out to know what the horizon was. So that one's going to be pretty easy. It's going to be points J and K. Which quadrilateral represents the top face of the figure? Well, if you look, the top of this figure is right here. And remember, quadrilateral has 4 sides. So when you name this quadrilateral up here, you're going to name it quadrilateral EFGH. Which quadrilateral represents the bottom face of the figure? Well, here's your bottom face. Remember, I told you D is the point in the back. So you're going to ABCD, and that's your quadrilateral. E says which segment represents the back edge of the figure? Well, if BF right here represents the front edge, then DH is going to represent your back edge. And it's segment, by the way, not line. Remember, lines have the point, the points on either end. A segment, why did I say that? Lines have arrows on either end, and segments have points on either end because they end. How many faces does the figure have, including the hidden faces? Okay, remember the dashed lines represent the hidden parts. So if you look at, here's the front, and here's another front face, and then here's a back face. Okay, a top face. So there's your 3 faces. Then you've got to look at the bottom face, which remember we identified that as ABCD. And then you've got a back right over here, which looks like CDHG, and another left back, which looks like AEHF. And altogether that makes 6 faces. Okay, what is segment DC? Now, remember, we're looking at D, the point in the back. So if I go from D to C, would be the same as going from B to C or from A to B. What are those segments called in this perspective drawing or a 3D drawing? They're always called an edge. This particular one, DC, is a hidden edge, and we know that because it's a dashed line. What are point E and H? What are point E and H? Okay, I told you all the corners, otherwise known as a vertex. Okay, so that's what point E and H are. They're vertices. Vertices is just plural of vertex. Okay, this cube shown has a front edge that goes from point B to point E. And there again, we've got point E and D sharing the same spot. Question A here says, in the cube shown, if AH is the length and AB is the width, which edge could represent the depth? So I like to go through and label stuff all the time. I love to draw and love to label because that's what helps you answer the question. So it tells us that AH is the length. So see how I highlighted that in green here? And then it tells me that AB is the width. Highlighted that in blue. Okay, which edge could represent the depth? That would be edge, which is segment BC. Okay, that could represent the depth. EF could have also represented the depth. AE and HG. I take that back. Not AE, it would be AD. And then for part B it says, what is a good definition of a three-dimensional drawing? A three-dimensional drawing represents on a two-dimensional plane the length, width, and depth of a three-dimensional figure. And that's what we have here. Okay, what we've learned today. I didn't go way far over, just a little. I'm looking at about 18 minutes right now. A three-dimensional figure has length, width, and depth. Depth can be defined as the distance from the front to the back of a figure or object, and a three-dimensional drawing represents a three-dimensional figure on a two-dimensional plane. And then we talked a lot about perspective drawings in that example, but I also need you to read up on those, and I showed you how to do an isometric drawing.